What's up guys? I make this video to share with you some of the things from my MCO restoration process that I think it might be helpful for some hobby guys, DIY or the home shop. I don't do this a lot because there are many professionals doing these a lot better, but from the perspective of 100% self-taught amateur like me, it could be a little bit easier to understand. This is a kind of boring content, so I really hope that somebody can learn something. Before we get into the details, the story about this machine is, you know that I didn't do a lot in the shop the last few years. Some pretty excited projects are waiting, and I never wanted to do another restoration video, especially the lathe, because I already did that 3-4 times. But I have to finish this one because my brother bought it like more than a year ago. Actually, I bought it for him. He was building a woodworking business. The reason is most of our machinery and equipments here are old and used. Also, we don't have much choice to buy things. The guy living pretty far from the city, the hardware center market. So it's very handy to have a lathe or milling machine in the shop, any kind of shop in general. So we could be able to fix things, make things and get the job done. So this is like a mini bench lathe, but it is actually a pretty good one with quite enough distance center to center, power fit both directions. Thread cutting gearbox without changing any gear. The milling attachment here seems a little bit inconvenience if you do a lot of milling, because you have to remove the compound rest, put on the vise, getting things indicated. It requires some time and patience. Also, the real problem is the saddle, the carriage on a lathe, not supposed to act as a milling table. When we're turning, the cutting force actually press the saddle down again to the bedways. And the V-ways here keep everything moving in straight line. Milling, on the other hand, mostly side to side and a little bit of pulling force because of the rotating helical fluid cutter that pull things upward. So in order to milling on this setup, you need to tie the saddle, the carriage, very good to the bedways. It does some space for things to move freely, but it should be tight enough to avoid any chatter or vibration. That was the reason why I did this on the uprun. After scraping, the carriage dropped out a little bit and leaving some space between here. So I made the bronze shoes for them to slide on the underside of the bed. The relief slots to minimize the distortion when I tighten the screws to adjust the tolerance, and the nut here to lock everything in place. I don't know if you can see the movement there, but believe me or not, without the relief slot right here, when we tighten the screws, it might bend the saddle here a little bit. Maybe not much, but if there is any unmatching surfaces, these things will wear pretty quick. So anyway, if you don't do a lot of milling and don't want to spend money for a separate mill or don't have a lot of space in the shop, this is quite a good option, do you think? So yeah, when I bought it, I just have to give it a good cleaned up, fixing some minor problems, then it's good to go. But the more I digging into the machine, the more problems I got. And when I already spent quite some time to making my own tools in order to transfer the number of teeth on some specific gears to my dividing head plate. To remake all the gears, bushing, I decided to go hard on it, completely rebuild the whole thing. So I decided to re-scrap the whole machine. Never do that before, so as I said, not so much excitement on machine restoration for me. So I tried to challenge with something new. So I made some tools, made some straight edge. The straight edge mostly look like this because it needs to be stable enough to remain the flatness. Also need to be as lightweight as possible for handling. I don't have a good one, so I made this from just a piece of scrap cast iron for this one-time job. It will be fine as far as we pay attention to what might cause some deformation to the thing. On this pretty long piece of metal, even with the heat from your hand touching it, will influence to the whole structure of the thing. Or like when you've done some scraping process, the ink got a little bit thicker and harder to get print. You clean it with some kind of liquid. So when we put liquid on this surface, the energy transfer to the liquid is more complicated than that, but basically the liquid get vapor pretty quick, and when it get vapor, it takes some heat with it. So this upper area colder than the rest, and then it gets shrinked a little bit, so the whole thing here will bend this way. Then we get a concave surface. The problem is if we keep on the work with that condition, we get a fall reading on the part. If we keep doing that for a little while, when this thing turns back to the neutral state, which means it's flat again, then we have another strange reading. We will get a final result eventually, but it might take a lot longer than we need, or maybe even forever if we repeat the same thing, the same problem. So make sure you double check your straight edge. I did it like every day, every time I start scraping. And in the middle of the process, I let it sit directly on the surface plate to avoid any distortion. Also, after you apply the ink or clean it, give it some time to normalize back to the neutral position, neutral state. I'm not trying to teach anybody scraping here because I am no expert. I did quite some scraping before, but this is my first time re-scrap the machine bedways. So just wanted to share some of my thinking solutions that I learned along the way. Sorry for not showing my face here because I actually reading my note. Anyway, we really need to have a trusty flat surface plate in order to scrape your straight edge as flat as possible. Imagine after spending quite a lot of time and efforts to re-scrape the whole machine and your straight edge isn't flat. It's no fun at all. Also, I have seen some videos showing people fixing the bedways with a hand grinding stone, and I'm not discussing what right or wrong here, but it's impossible for human to control the stone perfectly stay in the straight line. Also, how much material it going to remove, and some people fixing the bedways with a some sort of jig with a angle grinder. There are just too much error with that setup, the heat, the vibration, the runout, and also doing that without any reference. Maybe we improve the things a little bit, but it's not gonna last. So if you don't have the right tools, don't really know what you're doing, and just want the machine back to the working condition, just leave it. Gonna be fine with some basic machining jobs. Milling and turning is actually just some sort of rough machining process. We need to understand the principle of things a little bit here, but it's all just theory, so don't be so crazy about it. Even your straight edge isn't super flat, so your bedway is concave or convex, or all of the surfaces of parallel some degrees, but the carriage, the saddle only making contact with the bed in much shorter section of it, so it's gonna be fine. But keep in mind that the more we make it close to the perfect number, the better your machine perform and is gonna last longer. So this is the tool that I use to realign the bed waist. It's my clone version of the Herman King alignment tool. I don't know if it's okay to make a copy and even talk about it here, but anyway, we have a ball here as a pivot point for the whole thing to tilt, so we can measure the relation of two of the guys with a precision level. Also the indicator for these, and also this surface and the back as well. This is just a gate block for a better contact, rather than just a ball sitting directly on this pretty bumpy scrape surface. And this relief cutting here actually pretty important, because it's leave the base only touching the V-ways here on 4 legs, 4 feet, so there are no wiggle if the surface is uneven. Before I started the scraping process, I measure all of these distances, because we know during the operation the carriage never reached to this point, this section of the bed, neither the other end, so we know that these distances remain pretty much the same with the factory condition. And all of the surfaces need to be parallel with the center line of the machine. Also, they need to be parallel with the gear rack here, the lead screw, and the power feed shaft. So I scrape this surface first, and using 2 points of the underside of this surface as a reference to drop everything the same distance. And when I get it flat, I know that it remains parallel with the machine line, or at least close. Then I use it as a reference surface to re-scrape the V-ways. When I scrape the V-ways, I use this tool with a precision level to measure the relation between them. And these bedways need to be parallel with the surface, but also need to be parallel with this plane. So I use the indicator to measure the distance. When we got this bedway parallel with this surface, but it might be off this way or this way. So for example, if it's off this way, so we need to remove some material over here. If we remove the material over here only, the bedway here will drop down a little bit and it not parallel with the surface anymore. So when we remove the material over here, we also need to remove the material from the other side, the other end of this side as well. So this bedway will turn back to this way, also drop down the same distance. So it going to get parallel with this surface, also remain parallel with this surface. After we finish the surfaces, we got a pretty good reference to move on to these guys, and pretty straightforward. Another thing to keep in mind is when we scrape the bedways here and this guy, we need to somehow control the material we're going to remove, so both of them drop down the same distance. So then two of the surfaces for the cross line to slide in and out remain perpendicular with this plane. So all of this system not tilt this or this, that might cause some deformation to these guys. Also the gear inside here, the gear that's rolling on the gear rack here, remain properly matched. So we actually can adjust that distances when we re-scrape the underside of this saddle here, but the more we pay attention to things from the beginning, the easier we get along the process, and the more we make them close to the factory condition, they are not so much changing of all the components, so it's easier to keep them in the right order. When we measure things with a level, we need to stabilize the base as good as possible so there are no movement. Also, it needs to be in the neutral position. I mean, no climb or bolt down to something that might cause the deformation. This level doesn't need to be level with the wall, but this direction should be level as close as possible. And then, like, if we take this as a point, a reference point, we adjust it level and then move on to the next section. So after we done all the scraping on the bedways, we're going to use it as a reference to re-scrape the saddle and also the tailstock base. So make sure to measure all the original measurements to keep them straight, parallel and perpendicular as best as possible, and close to the factory condition. That way we don't have to adjust things a lot after all. And the most important part of everything for the better perform and how long your machine gonna last is lubrication. So all the moving things, whether sliding, rotating, gear matching, or even ball bearing, roller bearing, which not just rolling but a little bit of sliding movement. They are actually sliding on a very thin layer of lubrication, could be grease, oil, or even air. Without that, just two bare metal surfaces rubbing on each other is basically grinding action, and no matter how flat or how good the material, they are not gonna last. Like I said, this is a good machine compared to many other newer generations, but I don't know how they made it with very poor lubrication system. No oil access, no grooves, no waste cover at all. The only way to lubricate these things is put some oil directly over the waste and hoping they somehow get underneath them. They actually could penetrate a little bit to the end, but two contact surfaces will press the oil out of the way eventually. So we need the grooves for oil to travel all around the surface and keep them stay there as long as possible. Then it comes to the beauty of scraping, because the bumpy scrape surface actually better for containing the oil rather than super smooth ground or lapped. So I redo the whole lubrication system for pretty much everything here. Also made some better ways cover. After we done all the scraping, this whole thing dropped out a little bit, like for example like 2 millimeters. So the gear here, the gear that rolling here, 2 millimeters away from this gear rack as well. Also all of these components need to be dropped out 2 millimeters in order to keep everything in the proper position. Most of the machine, after the factory inspection, they have some kind of location locking pins to lock everything in the right order, but this one doesn't. It's kind of easier to adjust all of them rather than relocate the pins. Two of these guys need to be as straight as possible, because if it bent and when the machine running it keep wobbling around, is my influence to the whole system here. On some small machine like this, as you can see, a lot more weight over here in the front than the rest. So the center mass of everything here actually will tilt this thing like this. So when I loosen the clamp in the back of the saddle here, the whole system will tilt to the front. As you can see, quite some movement there. So if you run a machine with that condition, when we're turning some small diameter thing, the cutting force actually around here and press the saddle down, but when we do some bigger diameter, the cutting force move like over here, over this side, which already heavier than the rest, and then the whole thing will tilt this way. And two of these guys that turning, if they are not straight and wobbling around, and this whole setup like keep rocking back and forth, so then you will have a bumpy finish on your part or wavy We have to tight clamp in the back here as tight as possible for this side of the saddle making contact with the bed. So all of the weight of the whole system and also the cutting force will affect to the little piece of plastic or maybe steel, and it's not gonna last. So I add a piece of steel to the back here as a counterbalance for the whole carriage to improve the moving of the carriage a little bit stable. Here's the tool that I made to realign the headstock. Two of these guys are the same diameter. This one can be adjusted, so I can get them indicated individually, center with the spindle. Then I just move the indicator on the carriage to measure the distances and rescript the underside of the headstock to adjust it this way, and adjust the 4 set screw to tilt this way. So on the machine we actually use this section of the bed that close to the chuck, the headstock, a lot more than the rest. So this section will get wear quicker. So I left this side higher a little bit. That way, even when the machine got worn out over time, we still got more time using it with a reasonable accuracy. But one thing to keep in mind that this pretty long stick out thing, without support, the gravity will pull this thing down a little, depend on the material. So I'm using a piece of aluminum tubing to reduce the weight and minimal that error. Also, to align the tailstock with this technique, the gravity will affect to this side as well, and you will get a fall reading. Like, you think you got the tailstock dead center to the spindle, but it's actually lower some number, depending on how long the indicator stick out. So keep the indicator as close to the spindle as possible. And another better way to align the tailstock is turning a piece of steel that the diameter the same with the quill. Then just grip the indicator on the carriage to measure the differences between them. Again, I left the tailstock a little bit higher because it's moving and it will wear over time compared to the headstock. To realign the tailstock, I using the same technique to measure the difference between them. After we have done all the scraping, the tailstock always lower than the headstock. So I just put some copper shim under the base. But I also require the upper face of the base here to make sure that it parallel with the scraping faces under it. Make it to the specific number that I measure to lift the tailstock a little bit higher than the headstock. It's also the same when we re-scrape the cross-slide dovetails. As you can see, we use the back of the dovetails a lot more than this section, so the back will wear quicker. Then this cross-slide will turn this way over time. So when we re-scrape the dovetail surface here, we make it off a little bit this way. Again, they are just theory. The real problem is very hard to make things perfectly on the right number. So rather we take the number off this way, we take it off this way. Another thing, when you saw me regrind the base of this milling attachment, in order to align the spindle perpendicular with the table. So as you can see, we can loosen these screws, bolts, to tilt it this way, this direction. But this direction, I have to take it off, machine the back face here. So for example, if I want to tilt it this way, I have to remove some material from this side. In order to do that, I grind this back surface and left a little bit of step over here. It depends on the measurement that you got. You need to calculate, get the right height of the step that you left, and then you just flip it over, then regrind the face. So you got it tilt a little bit this way. And the reason I remake the whole swivel base for this compound rest is, as you can see, these original parts and the connection between them are ridiculously weak. Also, using this piece with only 2 screws to clamp everything down to the cross light on the T-slot. You can see it bent a little bit because someone already over tightened the screw, so it's not strong enough, and the deformation will affect to the whole cross light here. As I said, if there is any unmatching surfaces here, the thing will not slide smoothly. Also, they gonna wear pretty quick. So I made the pieces from ducker iron, the same wear resistant with cast iron, but stronger and better dumping vibration. Scrape all the matching surfaces for better contact, and using 6 screws to spread the clamping force equally all around this piece to the cross light to minimize the distortion. Also using 4 screws for this. And some people asked why I didn't heat treat the gears that I made. For my experience on a lathe, even some really big ones, those gears for those applications doesn't need to be hardened at all. The only gear should get hardened is the one that drives the whole carriage. The problem is the gear rack here is soft, so replace the gear here is much easier and cheaper than the whole rack. And for the plastic ones, as far as I know, is better, less heat, less noise, less lubrication required, and even stronger. And for the lapping, it's worked, but I'm new to this, so I don't feel confident to talk about. So yep, leave me a comment if you have any question. As always, thanks for watching.